A rocket explodes into four pieces of equal mass, and immediately after the explosion, their velocities are 120 meter per second east. So this is 120, 150 meter per second west, 80 meter per second south, and 150 meter per second north. We need to find the velocity of the rocket center of mass before the explosion. So of course, the momentum is conserved. So the final momentum first off we can find, and since the mass is same. So basically we can find the net velocity and then multiply it with the mass, right? So to find the net velocity, this is 150 and this is 120. They are in opposite direction. So that's going to be 150 minus 120 in this direction. And then on the upside, I will have 150 minus 80. So this is going to be 30 and this is going to be 70. This is what the direction of this is the initial velocity, net velocity of the, and this is the final velocity after the explosion in vertically up and horizontal directions. So, what is the initial momentum? Let me analyze this in two parts. In the horizontal direction, the initial momentum is going to be m over 4. Why m over 4? Because m is the total mass and it divides into equal mass. So, the mass of one is m over 4. M over 4 times 30, that's the initial horizontal momentum. And the final momentum is going to be, we do not know the speed, so let's consider it as v1, and let's say this is v2. So final momentum, in fact we have actually, this is the final momentum because this is after the explosion, and the initial momentum is going to be, let's say, mv1, because it was a total mass m. This means that mv1 should be equal to m over 4 times 30. M and m is cancelled, so the value of v1 comes out as 7.5 meter per second. This is the value of v1. This is the horizontal velocity. Then we talk about the vertical conservation of momentum. So the initial momentum will be m times v2, and the final momentum is going to be m over 4 times 70. So mv2 should be equal to m over 4 times 70. M and m is cancelled, so the value of v2 from here comes out as 70 over 4, which is 17.5 meter per second. That is the velocity v2. So if we are interested in the net velocity, initial net velocity, that's going to be negative 7.5 I cap, since it is in the left direction, plus 17.5 j cap. This is in the vector notation, and the magnitude is going to be 7.5 square plus 17.5 square, and the square root of this value is 19.04 meter per second. That is the magnitude. Thank you.